Welcome to homework.
So we have two cables loaded as such, cable AC and cable BC. They have a 1.98 kilonewton load pulling down on them at, that would be point C. Let's draw this B and then A just so we know where the points are. And then we have these distances here, which would be the height of all of your points, and then the distance apart between the points as well. So I will use that information to first help me solve these angles, because what we need to do is we need to solve the tension in AC and BC. So I'll just go down here a little bit. I want to find angle theta and phi. So, well, angle theta would be equal to the inverse tangent of the opposite over the adjacent side of that triangle, which in this case would be 3.4 minus 2 over 4.8. That's because we only want this here, because it would complete that triangle. And that gives us an angle of 16.26 degrees. And then phi would be the inverse tangent of 3.6 minus 2 over 3. And that's 28.07 degrees. So with those angles, we will go ahead and do some of the forces. I will do some of the forces in the x, and this will be equal to 0 because this problem is an equilibrium problem. So both some of the forces in x and some of the forces in the y will be 0. But the sum of the forces in the x will be equal to the tension in BC times the cosine of phi minus the tension in AC times the cosine of theta. And we can just go ahead and write that as the tension in BC times the cosine of phi is equal to the tension in AC times the cosine of theta. And for y, that is also equal to 0. Sum of the forces of y, that is. Tension in AC times the sine of theta plus tension in BC times the sine of phi minus 1.98. So let's go ahead and find using, equation 1 and equation 2 here. Using equation 1, let's solve for the tension in AC. So the tension in AC is going to be equal, tension in BC. Here, let me make that clearer. I'm sorry, tension in BC is equal to the tension in AC times the cosine of theta divided by the cosine of phi. And then we will plug that into equation 2. So it's going to go into equation 2. And we have tension in AC times the sine of theta plus the tension in AC times the cosine of theta divided by the cosine of phi times the sine of phi is equal to 1.98. So sine over cosine here will give us tangent. And we can solve everything here except for obviously tension in AC. So I'm going to give numerical values to all these trig terms and rewrite this as 0.28 times tension in AC plus 0.51 times the tension in AC is equal to 1.98. Solving for the tension in AC, we get a force of 2.5 kilonewtons. And then we can just use, actually I didn't number that one, did I? This guy right here, we'll call this one equation 3. And now we can just solve equation 3 using that value of the tension in AC. So the tension in BC is going to be equal to 2.72 kilonewtons.